Now we'll see about simulation in this slide. So um, what is simulations in that? We were seeing about some random normal distributions, random uniform distributions, all those things. So now what we can do is like we can generate random numbers using simple steps. So there are functions for probability distributions in R. So those functions are called rnorm, generate random normal variates with a given mean and standard deviation. Dnorm, evaluate the normal probability density with a given mean, so st at a point or a vector of points. Pnorm is evaluate the cumulative distribution function, form a normal distribution. And rpoise is generate random Poisson variates with a given rate. Now we'll see about those in detail. And probability distribution functions usually have 4 functions associated with them. The functions are prefixed with the d for density, r for random number generation, p for cumulative distribution, q for quantile function. Now working with the normal distributions, they require using these 4 functions, dnorm of x comma mean equal to 0, sd equal to 1 comma log equal to false. Same way, pnorm of q comma mean equal to 0, sd equal to 1, lower dot tail equal to true, log dot p equal to false. Qnorm of p comma mean equal to 0, sd equal to 1, lower dot tail equal to true, log dot p equal to false. Rnorm of n comma mean equal to 0, sd equal to 1. So this is how you can work with normal distributions using these 4 functions. Now how to generate random normal variates. I'll show these examples in our module. So if I create R norm of 10, you'll see just it distributes the random normal distribution of 10 variables with mean equal to 0. So this is what it does. So I can assign this to x, or I can do same thing. So now if I want to create R norm of 10 comma 20 comma 2, basically what I mean here is that I want to have 10 random normal variables with 20 as the mean and 2 as the standard deviation. Now if I create this, you will find that with 2 standard deviation you will find the values of random normal variates. Now same way, if I see let's say let us think like I'm assuming assigning the random normal variates to x. Now if I see summary of x, so you'll have the minimum value is 16.31, first quartile is 19.06, median is 20.11, mean is 20.08, third quartile is 21.43, maximum is 22.37. Now this is how we use random normal distributions. Moving on, so how to set seed. What basically setting seed means is that you can setting the random number seed with set dot seed ensures reproducibility, which means when you use set seed, these are random numbers. So when you generate random numbers, these random numbers are every time you use the function, the values of the random numbers, it is random, so hence it changes. So now if you want to remember particular random normal distribution, you have to set seed so that the language R, it takes the effort to store these values of these random normal 5 variables. So for example, if I set dot seed of 1, now if I create R norm of 5, you'll have these values. Now if I use R norm of 5, you will see that the values have changed. So what if I want to retain the values? Now if I want to retain the values, what I have to use is set dot seed of 1. So for 1 the seed has been stored. So now if I use R norm of 5, hence I will get the same values that are being stored when I use set.seed of 1. So that's the reason we need set.seed. So whenever you perform simulations, you have to be careful when the values are getting lost. So hence you need to use seeds to store the random values in case it gets lost in the data. It is always recommended to set the random number seed when conducting a simulation. So now we'll see about generating random numbers. It is generating Poisson data. So what is Poisson data? Is basically it's a level of Poisson distribution. It's the same as this is a Poisson distribution, and the variables will be variates will be distributed in the follows the Poisson distribution. So now as you can see, these are, if you plot in the graph, you'll get the Poisson distribution. So for example, you can do R Poisson of 10, 2. Same way you can go ahead with like all R Poisson of 10, 20, where you get the values 20, 11, 21, 20, etc, etc. Now if I want to create a cumulative distribution, what will happen is if I want to create P Poise of 2, 1, then I'll get this. So which is basically nothing but the probability of x less than or equal to 2 here. So here it is probability of x less than or equal to 1. So probability of same way P poise of 4, 2, probability of x less than or equal to 4, which is the mean here, and again probability of x less than or equal to 6 is 0.9954662. So this is how you generate Poisson data variates from the using the functions.